Yes. Now student, we start how to find the inverse of matrices by the method of determinant. It is an important topic. So we first find out the inverse of 2 by 2 matrix. Now 2 by 2 matrix, I told you inverse of matrix is exist if its determinant is not equal to 0, means it is non-singular. So first check whether it is equal to 0 or not. Now determinant of A is 3 to the 6 plus A minus minus plus A. So it will be equal to 14. So it is not equal to 0. So this implies it is non-singular. So A inverse exists. Now A inverse is exists. So now we have to find out adjoint of A. Adjoint of A means first A11 का adjoint, delete first row, first column. So element is 3. So A11 is 3. We write down in that order the elements are there. So in that order we write down their cofactors. A11, A12, A13, A21, A22, A23 like this. In the second row, first row as it is first row, second row के cofactor second row में लिखो. Then it is very easy to write down its adjoint. So A12 is minus 2. So deleting first row and first column. So remaining element is 4 plus, after plus the sign is negative. 1 plus 2 is 3. So that's why we have put up the sign minus 4. A21 it is odd. 21 is the odd. 2 plus 1 is 3. 3 is odd. So we have to put up here minus sign. So deleting second row, first column. So element is minus 2. So this minus 2 become plus 2. A22 second row, second column. Delete. So remaining element is 2 and 2 plus 2 is 4 even. So sign is plus 4. Now adjoint of A means we have to take its transpose. So first row become first column. 3 minus 4 is the first column. 2 is the second column. And remember A inverse. A inverse means 1 upon determinant of A into adjoint of A. We calculated determinant A is 14. So 1 upon 14. Adjoint of A, write down this matrix. So this matrix gives us the inverse of A. So this is the method for 2 by 2 matrix. Now come to the 3 by 3 matrix. 3 by 3. 3 by 3 matrix. It is your question number 7 of your exercise. Now we have to find out inverse. So first of all, find out the determinant of A. Determinant of A means we expand it along first row. So 1 into determinant 2405 minus 2 determinant 0405 plus 3 determinant 0200. Here row, second row is 0. Here first column is 0. So these two determinant value is 0. Only solve this. First determinant 10 minus 0. So it will be equal to 10. That is not equal to 0. Means A inverse is exist. Now we find out a cofactor of each element. Cofactor of each element. Remember we have to take the sign plus, minus, alternate. So in the beginning you must write down the sign so that we cannot forget it. plus minus plus minus plus minus. Write down first the sign, then write down its determinant. A11. First row, first column is deleted. 2405. Open the determinant. Value is 10. A12. First row, second column is deleted. 0405. Here first column is 0. The value of determinant is 0. A13. First row, third column deleted. 0200. 00 is the row, so that's why value of the determinant is 0. Similarly, we find out the other cofactor by deleting the row and column in which the element is exist. So open the remaining determinant, and remember again the sign should be alternate, plus minus plus minus. So it is better if you write down in this way that I had written, so that you can easily transpose it. Means first row cofactor in the first line, second row cofactors in the second line, third row cofactors in the third line. Now transpose it. First row now become first column. So 10, 0, 0. It will be the first column. Minus 10, 5, 0. It will be the second column. 2 minus 4, 2. It will be the third column. So this gives you the adjoint of A. So A inverse is 1 upon determinant A into adjoint of A. We calculated earlier determinant A is 10. So 1 upon 10 and write down the adjoint of A. So this is the second method of finding the inverse. If in the question it is given to you, it is asked in the question, it is asked the question that you have to find out the inverse. Only the question is find the inverse of the matrix, then it is your choice. Either you find out the inverse by transformation that you had studied in chapter 3 matrices, or you apply this method of determinant. That is your choice. But if it is mentioned that find out the inverse by transformation, then you have to use either row or column transformation. Or if it is mentioned that find out with determinant method is easier than the transformation method. Here you must be careful in the calculation work. Otherwise, this method is very easier than the transformation method. I hope all of you understand this method. Do practice of this method, because when you maximize practice, then your mistakes will be minimized. And then we come to the next exercise. Then the you practice use of this inverse in practical life question and solving the equation. We use this, and that is also the important topic. Clear? So do maximum practice of finding the inverse by determinant. Now come to the exercise again. Now come to the question. Here the question is, if matrix A and matrix B are given to you, then you have to verify AB Product of AB inverse is equal to B inverse A inverse. Remember, in the last video, I given you this result to you. Now we have to verify this result. Now left hand side is AB inverse. So first we find out AB, product of the matrix. Remember, first row की, first matrix की row and column of the second matrix. Hope all of you remember the method of multiplication of two matrices. So 2 into 1 plus 3 into minus 1. First row, second column, 2 into minus 2 gives you minus 4 plus 3 into 3 is 9. Similarly, second row, 1 into 1 plus minus 4 into minus 1 is 4. 1 into minus 2 plus minus 4 into 3 gives you minus 12. So AB is minus 1, 5, 5 minus 14. To find out its inverse, first we calculate its determinant. Its determinant is 14 minus 25, that will equal to minus 11, not equal to 0, means inverse exists. Now, to find out its inverse, we have to find out its adjoint. So, A, B, 1, 1. First element deleting. So, you get first row, first column delete. Answer is minus 14. First row, second column deleted. Answer is 5. And here sign is of minus. So, it will be minus 5. Second row, first column deleted. Answer is 5. And with 2 plus 1, 3 minus. So, it will be minus 5. Second row, second column deleted. Answer is minus 1. So, take its transpose. Transpose is, this become now first column. Minus 14 minus 5 is the first column. Minus 5 minus 1 is the second column. Now, its inverse value of the determinant is minus 11. So, minus 1 by 11 adjoint of A. Taking minus common from each element. Remember, in matrices we have to take common from each element. Each element से minus common ले लेंगे. So this will be the AB inverse. Now same way we find out A inverse and for B inverse. Determinant of A is minus 11. Find out adjoint and then its inverse. Determinant of B is equal to 1. So, find out its cofactors and then adjoint. B inverse you find out. Now, multiply when these two B inverse into A inverse. Read it carefully and do the calculation yourself. Then you see beta. B A inverse means B inverse into A inverse. Multiply these two. Remember again same multiplication. Row of first, column of second. Order is B inverse A inverse. So first write down B inverse, then write down A inverse. Multiply these two matrices, you get the same answer. So you check left hand side is equal to right hand side. So now beta, now you complete exercise 4.5 up to question number 12. So that's all for today. We continue tomorrow.